Hello, everyone. Welcome to our last binary episode of the Day Zero podcast for the summer break. I'm Specter, with me is Z. And yeah, so after this week, we'll be going on our usual summer break. We'll be returning September 25th and 26th. We'll still be doing some other content over the summer, just not the regularly scheduled podcast. We'll also be going to DEF CON this year, so if anyone's interested in meeting up or anything like that, check out our Discord and hit us up there. And for anyone heading to Hardware I/O this year, I will be going there next week. I'm also going to be giving a talk on PS5 console security, going into some insights on the hypervisor and overall system security and whatnot. So if that sounds interesting to you, especially if you're from got here from the console hacking space, that'll probably be of interest to you. I think the talk should go up pretty soon after it's given. They're not shown live like CCC, but usually they go up like within a month or two, I believe, of the conference. So it shouldn't be too long of a wait on that front. So yeah. With that said, I'll let Z get into the Spot the Vuln stuff here.
All right, yeah, this week's Spot the Vuln. And actually, I will also mention, before I jump into that, with DEF CON, we've mentioned on the last few episodes, planning to do like Spot the Vuln shirt if anybody else is interested in those. If you have like a favorite Spot the Vuln that we've done, let me know or DM me on Discord or something. Just try to decide, what should actually be on there, what would be a good one for the shirt and stuff. So if you're interested in that, those shirts will probably just be on our Discord at some point if anybody's interested in it. So now, the actual vulnerability here. Code op is a little bit of Python. Supposed to represent some sort of Python web app. I wasn't really following any particular framework in writing this. Just you've got this, the top here, just cserv check, which takes in the request, checks the refer. So the idea of this cserv check is literally just making sure whatever the refer is, it is from an allowed location. So you've got the extract, and I guess I should say basically it's not really, I maybe shouldn't have called this quite a cserv check. I've seen a few things with this. Because with the cserv check, you are going cross origin, so the refer should not match us up. So it does provide some degree of security. I just absolutely hate seeing this sort of defense actually used in practice versus a token, which is a well understood, strong defense against cserv attacks. Whereas checking the refer is if you're checking the domain, as long as you don't have any on-site request forgeries, it is technically can work as long as you do this check right. It just feels so fragile to me. Anyway, the way I've implemented this check, we've got the extract domain, does what you'd expect, uses the URL lib.parse, pull out the netlock. So it's pulling out the domain, plus a little bit of extra. Because I think that'll include, if you have credentials in it or something like that. I think that gets included in netlock. So it's not just the host, but it's good enough for our purposes here. Check refer is finally the actual kind of main code here that matters. Checks the request method, so get requests don't need any checks, so it just gives you a true. In theory, you should never do anything that modifies or changes state on a get. People break that all the time. But in this code, I'm just going to run with that assumption that get requests don't need to be protected. But if you found such a get request, that is something you could attack with this setup. And it is something actually to keep in mind when you do see these sorts of checks that only apply on post requests or something. Because every so often some dev unaware just makes it a get request or something. But now we get into check refer. So grabs the refer of the header. If the refer is set, goes in and checks the expected set, or has an array of expected domains that it'll allow. Checks if it's in there. If it is in there, it'll return true. Otherwise, it also goes through and looks for the subdomain by just putting a dot before the allowed domains and seeing if the referring domain ends with that domain, including the dot there, so you can't register example.com and have it match to example.com. Needs to have that dot in place. Returning true, and then if those fail, returns false. The core bug on this one is it doesn't return false by default. There's no, like, if this refer check doesn't match, there's no return down here. So it's just going to return a none. It's not going to return anything in that case if the refer isn't actually set. So if you go and use, on the attacker website, if they were to use something like one of the meta headers where you set here the refer policy meta headers and just say like no refer, it won't send the header at all. And then this check will basically pass every time because there's no refer. So it's really just about noticing that they're not actually checking for that edge case. And it is something kind of easy to overlook, especially on the developer, because you read through the code and just reading it top to bottom, you see that return false apparently kind of working as like a fail safe, but because it's kind of applied at the wrong indentation level, it'll end up basically not returning false. And I guess that is an important thing up at the top here. It's doing the check refer thing and checking that it's equal to false to handle like the bad case. If this were to do something like just a treat check refer as a truthy value or a falsy value, and doing if check refer without equals false, then this would actually kind of catch the non-return type because it'll have the implicit conversions and all of that. So there is a little bit of a scenario on that, but ultimately I'd say the bug comes down to just not watching for that edge case.
Yeah, sort of a fail open type situation.
Yeah.
Which is always a fun type of bug to see. All right, so getting into some real vulns. Up first, out of ZDI, we have 2 vulnerabilities in VMware Workstation coming out of Pwn Vancouver from this year. This chain ultimately earned an $80,000 reward and 8 Master of Pwn points. Z, I'll let you get into the bugs here.
Yeah, decent bounty on these. And they're both in a Bluetooth implementation VMware, so allowing the host to share Bluetooth devices with the guest operating system, which is something that is enabled by default. So the guest operating system can send, their packets over to this virtual Bluetooth controller, and it'll do the proxying and all of that to the host machine. First vulnerability is an uninitialized variable info leak. And what it comes down to is in the request going to the virtual device, the client is able to provide a size variable, and it ends up being written into this actual size. Sorry, and if you're watching, just got the Squarespace screen that always happens when we cover CDI posts, because the button I use to hide these squares that I draw on screen is the same button to bring that up, because they need that feature on their website. Anyway, what you've got is this URB actual size variable that is being set with an attacker controlled value. It's setting a size that isn't too crazy. Like, that an attacker can indicate a size. I don't quite like the naming of that, but I'm not sure if this is reverse engineered naming or if this is where the names are coming from, because this does seem to be reverse engineered. That could just be their call, in which case, whatever. Doesn't matter. Anyway, actual size variable. And what generally happens is you have your packet, it has the opcode, and it's going to enter some handler. It'll enter whatever handler. That handler will end up writing the actual size into that structure. So whatever the attacker put there just doesn't matter. The handler is going to overwrite that with an appropriate value. But if you give it an invalid opcode and basically have an invalid request, it's never going to hit that handler. It's never going to overwrite that actual size. And so it's going to keep processing. However, it's going to send this stuff through, and ultimately it ends up reaching the URB response function, where it just trusts that actual size value, takes that actual size value and uses that value as how much data to send back or send over to the guest. Does the copy using it. It just sends it back. So that can result in the uninitialized value read. I think it's kind of a fun bug where you do have that, just, again, it's about tackling the edge cases and thinking about those edge cases. This works under the normal scenario where it hits a handler that does everything right, and then fails when you hit the edge case of what if it's an invalid packet. That doesn't work, never hits the handler, actual size is now attacker controlled, and thus leading to the uninitialized value. Or, well, potentially. I mean, it's an overread, so it's going to copy too much data, which is potentially uninitialized or just extra data off of the heap.
Well, to be fair, I think it is still within bounds of the buffer. Like they say that it's bounds checked there. It's just that, where they don't zero the memory or whatever at time of allocation, whatever memory is not used in there is just going to leak through. So
Yeah, I
by
guess.
being able to provide like an artificial size, you're not bound to the amount of data that was actually written into the
Yeah,
buffer.
yeah.
So yeah.
Sorry, that is kind of what I meant there. Like, the uninitialized data off the heap from like what wasn't initialized, what wasn't actually written. But yeah, good clarification. And I was highlighting the line that had that condition check there. Like they are doing some. And then yeah, leading into the stack-based overflow, which was the second bug they had. I feel like we don't get a lot of information here about some of the details on this. The gist of it, how they explain it, just comes down to the sending SDP packets, a service discovery protocol. Send these packets, open up the socket, so you can send these packets to it. It ends up invoking this read element function. Read element will try and determine the size. It's got this switch statement where it's just switching over basically different types of ways that size could have been sent there or fixed size. And it has this LE size variable that gets assigned depending on whatever case. In a few of these cases, it seems like that ends up being a fairly dynamic value. In some of these, it's just hard coded. Ultimately, that value gets passed in to this read raw int function, which ultimately leads to it being used in a mem copy, leading to writing too much data onto this stack buffer.
They just straight up don't check the length of the size going to memcopy, it seems.
And this one, yeah, they're not checking the size at all. It's just using the size that's provided. The couple things that don't make sense is one, they don't really talk about exploitation at all here. This is, it leads to a possible stack overflow, is what they mention there. And they mention how the attacker can control the size argument. They don't talk about which option they fall into for their control. Looks like I don't know where all of these variables are exactly coming from. Seems sane to assume that it's probably this 5 one because it kind of has a really clear direct control versus having like a rotate left or whatever's going on in this one. Looks like it's doing some an Indian shift, maybe. I don't know.
Which line are you looking at?
Line 40.
Oh, I believe that's that's reversing Indianness, yeah.
Looks like it might be Indianness. Like it's doing some shifting on the value, whereas at least 5 is something else. Either way, one of these options gets them in there with the attacker controlled size. But yeah, I feel like they just gloss over a lot of detail over how this one works, and we don't really know anything about the buffer they're landing in besides that it is a possible stack buffer overflow. All of the functions they include, this is just a magic pointer that we have coming in somewhere on the stack. So
yeah, I wish we had a little bit more information on what the stack buffer or what the stack frame looks like of where they're getting their overflow. Because one thing I was thinking about here was like towards the end of the post, they say that they took it to code execution and they show popping calc on the host machine. So we know that it is exploitable. But that question always comes up when you're talking about stack overflows. Is like, if stack canaries are in play, I believe they should be in VMware. And with the type of info leak they have, where it's so restricted, like it's not like you're able to read out of bounds data or something. It's just an uninitialized leak, so you're kind of limited in how much you can leak, and from where. Like you're only really going to be leaking from the heap. So I don't think you'd be able to leak stack canaries or anything like that. So my guess is they're probably hitting some other data on the stack, like some other pointer that's not protected, instead of going for like the return address or something. That said, I can only like speculate and guess at that because they don't show the state of the stack of where they're overflowing. So I do wish there was a bit more information on that and just a bit more information on the exploitation in general. But with ZDI, it's often you don't get that information, so we're just left to speculate. That said, these are pretty cool bugs. Not too surprising that these low-hanging fruit style issues were found in the Bluetooth driver. Seems to be like across the board. Bluetooth is a pretty weak spot and just something that sucks to deal with, and people don't like dealing with it. So it's just kind of like rushed code,
Yeah,
not well combed over.
it has that complexity in terms of hitting it. Like they do talk about needing to go through this process to actually open the socket to it to start sending the SDP packets over to it and such. So there's that added complexity. But yeah, I like the bugs. I thought the first one was kind of the more fun bug out of the two. Again, I always like those. I mean, it's an edge case. It's just not dealing with that one edge case. They're always fun to
It's
see
sort of similar
because
to Spot the Vuln in a way.
in a way, yeah. It's one of those things that feel like it gives you a bit of inspiration when you start dealing on other software for, well, can I apply the same edge case to other things? And there's other software where you're going to be able to send things with opcodes and give it a wrong opcode and see what kind of falls out of that. Granted, that is probably already a test case you try. Like that's not exactly a complex test case, but looking for those edge cases in the air handling and all of that, yeah, they're always fun.
Yeah, it's a good source of inspiration. Even if it does seem obvious, it's we kind of say it. We've said it before, but like it's easy to forget those obvious edge cases too. So yeah, a good reminder of that.
Like with last week's one, it's easy to focus on the complexity and not the
Not the dumb
like
error cases. Yeah,
that, and like it's easy to focus on the code that's there and not the code that's missing.
yeah.
Because that's another thing. Like it's so easy to look for the vulnerable code and not the lack of like the checks. If
So
that makes sense.
yeah, I think that's a good way of capping it. Yeah, so getting into our next post from Neodyme, we have vulnerabilities in CS:GO. So yeah, details 4 bugs in CS:GO that were patched at the end of April of 2021. Mostly logic bugs, which is interesting because pretty much every time we've covered source engine topics in the past on the podcast, there were memory corruption. I think they actually comment something to that effect on this post. So it's pretty rare you see these types of logic bugs in source engine being talked about. And yeah, so getting into the first bug, they talked about privileged commands. So if you played CS:GO before, you probably know that CS:GO you can enter commands in, and there's also like privileged commands. So things like quitting the game, the quit command, and the intent is servers can send unprivileged commands to set up certain things that they need to, like CVARs or whatever. But privileged commands are privileged off. They can't be used. But the nuance comes into play is that there's 2 types of servers that you can have in CS:GO. You can have single player servers and multiplayer. Single player servers can execute the more privileged commands on behalf of the user for things like changing keyboard settings and whatnot. And then multiplayer ones are more restricted. And the way that they actually determine which type the server is by checking this max clients variable. The problem is that's controlled by the server itself. So by the server just pretending it's a single player server and sending 1 for that variable, the client will think it's a single player server and it'll allow privileged commands to be executed. So just kind of misplacing trust in like where the data is coming from, I guess, is what that one boils down to.
Yeah, I thought there's kind of that misplaced trust. There's also almost trying to be too smart by using a value that's technically unrelated to it. Like I guess you could say a single player server is one that has max clients of 1. Like that is kind of a fair assumption. Um,
But it is kind of a hack as well.
yeah, it feels very much like a hack to me, where it's that isn't the right value to be using for that. Like it's kind of like accurate to say that, but like I said, that's just the server reported value. It's not
It shouldn't
the
be considered
intent.
trusted. Yeah.
Yeah. Like it would be better to look at what is the player doing and kind of tracking a bit of that state on the client to say, am I intending to connect to a single player server? And kind of looking at that perhaps. Or I mean, I don't know, it does get a little bit tricky when it comes to trying to determine what the server supports without um trusting
Like
that
you
server.
kind of have to put some trust in the server. Yeah.
Yeah.
It's a
That's
bit of a tricky scenario to handle for sure.
yeah, that's kind of why I'm getting at using more the client-sided intent at that point. Like that's something you'd want to look at and enforce on the client side rather than I mean, I guess this is on the client side regardless, but by looking at the state of the client rather than the server that they're connecting to. It does create a bit more like spaghetti code when you have to have this concept of the single player server that isn't kind of sitting in the same code, most likely as everything else, because you have to track it through the state. Um, but yeah, I mean, just this feels like a hack anyhow, and obviously kind of bit them a bit.
Yeah, so from that ability to send privileged commands, that's where the other bugs come into play and chain on top of it. Bug number 2 was an arbitrary file download. So another thing that Source supports is the ability to play custom maps and such. And to do that, it has to be able to download the assets. They try to do some filtering on this to prevent the client from downloading like executables or linked libraries or anything sensitive like that. And these files can be downloaded from the server directly or over HTTP if this fast DL variable is specified. The problem is when they're building the file name of where to like write the file to, it truncates to 256 bytes, and the file name is built with by using the server name and the file name concatenated together, each of which can also be 256 bytes. So by just passing a large string between the two of them, you can get the extension truncated and bypass the filter. The third bug is an arbitrary text file write. This one's the shortest in detail and simplest. It's basically just the fact that by using con log file, the con log file command, they could write arbitrary log files into arbitrary game folders. And again, like the second bug, it was vulnerable to that same truncation issue. And so you could also have an arbitrary file extension. Finally, the fourth bug is the ability to launch the CSGO client in insecure mode, or rather switch it into insecure mode. So in a usual launch of CSGO, the integrity of the game's assets, particularly libraries, are verified. And if they're not validated, you can't play on official servers, for obvious reasons. They don't want you to be able to connect to official matchmaking with a modded client. But if you launch with the insecure flag, those checks aren't performed. And you can also load DLLs outside of the game's binary directory when the insecure mode is set. And you can set this insecure mode by simply causing a DLL verification failure. And get your attacker crafted DLL from the previous bugs loaded and executed. Of course, you can't overwrite DLLs that are loaded in a running process, so they had to be a little bit careful of trying to choose something that they would be able to overwrite while the game was running in the attack. And they ended up finding one that wasn't loaded but is still verified, being client.dll. Little bit of history there. Basically, that file was superseded when panorama mode was added to CSGO, which is when they redid the menu from the old somewhat like blocky UI into the more fancy one. So that client.dll just kind of got deprecated, but it was still verified. It just wasn't used, so they were able to leverage that to switch the game into insecure mode and launch their hijack DLL. So yeah, kind of an interesting chain. It is more logical bugs than what we typically cover on the podcast. And like I said, it's interesting because I don't think we've really seen logic bugs used in this way from Source Engine. Typically, when you talk about Source Engine, it's your memory corruption chains, which we've covered a few of in the past. So
Yeah, and was definitely expecting this one to be that. So unfortunately, when I was reading it last night after the bug bounty episode, I mean, this probably would have been better on our bug bounty episode, in fairness. Although it is kind of a reminder that even in these native applications, it's not all about the memory corruption. Um, we're obviously focused on the binary level exploitation, but I don't know, these bugs are obviously becoming more common, and these sort of more functional, more this isn't what I'd call a data-oriented attack, but it is still kind of abusing the game's data. So, like, you have that pulled over. Like, they are bugs that you should be thinking about when you're doing your auditing. Like, might enjoy the binary level bugs more. These sorts of bugs are definitely very impactful, harder to detect in a lot of ways. And in some ways, it can be easier to, like, detecting misuse of some of the commands can be an easier thing in some situations, but yeah, it's
Mainly, it's just not touched by a lot of the mitigations where effort is being put into,
yeah,
because you're not corrupting memory really. You're just abusing intended like intentions of the code. So, yeah, it's fun to see those when they crop up.
yeah, and
Outside
that
of the technical, go ahead.
it's going to say the truncation issues, really remind me of old PHP bugs where you'd be able to do the same with like file includes that had the .php appended in them, give a really long string, and you can get like the .php truncated when you hit the max path length. Uh, had a very similar feel to that. I mean, it's a classic trick in dealing with file upload restrictions or extension restrictions to at least check for very long file names to see how they handle them and if you can get things truncated.
So,
I
outside
mean,
of the technical details, sorry, did you want to add something on there too?
no, go ahead.
Okay. Outside of the technical details, the timeline was kind of interesting. We don't tend to talk about these as much anymore because they got a bit repetitive, but especially when you're talking about Valve, they tend to be a bit more interesting. We've commented on Valve's HackerOne program before and how ridiculously slow and unresponsive they are. So this bug was initially reported back in the beginning of 2020, and there was some back and forth throughout the year where HackerOne struggled to reproduce the issue. The researchers here continued to try to make it easier and easier, and eventually they figured it out, passed it on to Valve. Um, and yeah, so then in 2021 they asked for updates, still didn't really get any, and finally in April of 2021 Valve shipped a fix for these issues, and on May 1st they were paid out. So at least like between the fix and being paid out, that was pretty quick. But then, yeah, they still didn't get like any communication. March of 2022, they asked to disclose the report, and still to this day, it seems they didn't get a response. So they just decided, it's been like 3 years since we reported this vulnerability. Let's just go public with it, which I think is fair. Um, but yeah, it's just another reminder of the unfortunate fact that Valve products are like seem like a really fun area to do research in. You can find some pretty cool bugs there. They also pay out pretty well. Especially at the time, I think they were still paying like the $10,000 or whatever for full RCE, which I'm assuming is what their bounty was here. I don't think they actually say what the amount was. Um, but yeah, in terms like you will be paid a lot. It just might take like 10 years or something. It's like when you win the lottery. It's like you don't get that money right away or even a response right away. So yeah, there's a lot of information in the timeline here. It took them a while to acknowledge the issue and fix it, and then they just never responded on disclosing it. Bit unfortunate, but that's just how Valve be Valve.
I mean, it's
I guess it's
unfortunate. It's also like by disclosing it, they can also just end up being kicked off of HackerOne because of that.
technically speaking, yeah.
Um,
They could be found in violation of the HackerOne guidelines, yeah.
which, in fairness, like I don't agree with. I'm just stating the fact that HackerOne, like they definitely can be kicked off just for doing this disclosure, even though this was fixed so long ago.
Yeah.
Um, if you want more on that topic, we talked about it yesterday. Well, we talked a bit about issues with bug bounties on yesterday's episode.
I was just about to say this ties in perfectly with Pi3's blog posts as well. So yeah, definitely check out yesterday's episode if you're interested in more of the meta discussion around that.
Yeah, and in
Uh,
terms of the timeline, like I don't know. I thought I had heard that Valve was actually improving a bit in trying to take something more seriously in 2022. Although seeing this, that they did their disclosure request and had no response all throughout 2022 makes me question that. But I had thought I heard things were improving over there. That they were making significant changes to kind of their structure, how they were running things. Maybe that's not the case, but yeah, I don't know. I mean, because this is kind of old. And kind of side note, I love the fact that they just sent happy anniversary when they asked for the update
Yeah,
after it was
that
a
was a good
year
one.
old.
Yeah, I like that. Yeah, it could have just been a case of something that fell through the cracks, in all fairness, but yeah, hard to say.
They have a history of things falling through the cracks, though.
That yeah, it's hard to give them benefit of the doubt for sure.
Yeah. Like, that's kind of the problem. I've heard that, but this is a clear example of it. Like, it's still happening.
Yeah. So moving away from things that weren't really reported, we have an ODA in the wild post from Google Project Zero on an issue in Windows activation context. And Z, I'll let you take this one away.
Yeah, so the core of this bug, I think, is relatively easy to understand. And at its core, like, the root of this bug was actually reported back in um, 2015 with James Forshaw bug report. Bring that up here quickly. Uh, Root of the vulnerability, though, is as an application starting up, like a privileged service is going to be able to, or may need to, for whatever reason, impersonate other users. You take the token, exchange them, be like, hey, give me these privileges or whatever. Goes through that process. If you're into the Windows stuff, you can dive much more deeply into how all of that works. Uh, but the gist is they're taking over or impersonating as another account. And in that process, they're going to, when they impersonate, they're also going to take over. Like if that user has, in this case, if they have remap or any of their like remapping that's happened, all of the file access here, as it's mentioned here, impersonations used by many privileged processes in Windows. During impersonation, all file access are performed using the DOS device map of the impersonated process. So, if the user has used their symbolic linking to remap the C drive, the privileged process will now end up using kind of all of the remap that they've done, so they can be tricked, or that privileged process can be tricked into loading like the DLLs or arbitrary files, whatever it's actually trying to load, from unexpected locations because of this remapping. And it really is, in a sense, that simple. It's just redirecting where the privileged process is going to load. So, kind of think of like some of the DLL redirecting tricks that have existed, kind of in line with all of those. So yeah, fairly straightforward. I thought it was interesting that, like, at its core, this bug was reported in 2015, where the report here was when an application impersonates another user, all file access are performed using the current DOS device map under that token. Same issue, just 8 years ago.
Yeah, I guess I made a joke at the like transition of this topic of things not being reported, but yeah, this one was, and it just kind of got lost through time, I guess. I noticed that the report was fixed. I didn't take too close of a look at this report. Is there like any comments below of like how they fixed it? Because the way that this works, because the top of the Project Zero post basically says that this was fixed for the print spooler, but the underlying root cause wasn't fixed. So just kind of one of those cases of like, patching up a hole with gum or whatever instead of doing a proper fix, and there was another hole and that allowed it to be exploited, in this case through the activation context. So yeah, I guess just a incomplete fix, which we talk about a lot of the times when we talk about it, it feels like it happens with Windows. I don't know if that's just a coincidence or like a bias, but in
It
fairness, this does
happens
seem like
everywhere.
something where it's
We've
just we
talked
seem
about
to
it
see it more
on
with Microsoft.
Yeah, we've talked about it on Linux. So I think a big thing is Microsoft especially gets the patch diffing done. Like every patch Tuesday, people are in there to go patch diff.
There's a
Um,
lot of incentive to do so. Yeah,
yeah, and I feel like on Linux, like looking at the patches absolutely happens, and looking at the commits and all of that, like people are doing it for sure. But I feel like the drive is definitely a bit different. It's a lot more of just the code analysis rather than really looking at what the change. Like, I don't know, people. I don't know how to put into words, I guess, but I do feel like there's.
basically, I think there's a shift in the audience of people who are doing the patch diffing between some other operating systems like Linux compared to Windows. I think you have a lot more like people doing it with malicious intent, like trying to find variants or incomplete fixes, in the intent of like using them on Windows. And part of that, it comes down to a debate that we've commented on before. I think it's been a little while since we talked about it, but kind of the open source versus closed source debate. Whereas where you like when you have open source, some of the people who are more on the defensive side are more, uh, more likely to look at the diffs and report them because it doesn't require a huge amount of effort to even find them. Whereas in Windows, where everything's closed source, for the most part, the people who are going to have the resources and time and effort to dedicate into looking at the diffs are probably because they're looking to attack it, not because they're looking to keep it safe. So, it's just kind of a different audience, I guess, and who's doing the diffing is how I would put it.
Yeah, I think that's fair. Jumping back onto this vulnerability though, talking about the fix, back with the fix actually, with this 2015 bug, Mike's they haven't mentioned here. Microsoft introduced a new flag, object nor impersonate device map, which turns off impersonation during load library. Talking about the printer bug, the legitimate print config DLL will be loaded. During the loading process, CRSS will create the activation context, and it's in the activation context, which is where this bug specifically exists, and we'll still use the old remapping. I guess I probably should have talked about that a little bit more uh, at the top of this topic, but like the difference with this one, so the 2015 bug was just this root bug. This one specifically is the activation context is still using that device map, which is kind of what telling you what files to load, path, things that it depends on, and all of like the dependencies and all of that are being configured at that stage when it's creating this activation context. So that's kind of where this bug still exists. So yeah, patching it was just introducing this flag and inconsistent checking of it, I guess. Well, I
Yeah,
guess
fair
the
enough.
fix would have been having more consistent checking of it.
Fair enough. And yeah, I guess I'm not too surprised given like the relative complexity of what's going on here that something like this would slip through. So, yeah, fair enough.
Yeah, I'm going to be honest. Like, I'm trying to explain the bug, but I don't know Windows super well.
It does have a lot of unique nuances to it, especially when you get into like these sorts of bugs,
Has a
where
lot
it's
of
like a
things
missing
that
check.
are, uh, I mean, in a sense, unique, but there's only a few operating systems. So, like, you've got your Unix variants, you've got Windows. Um, like, ultimately, you don't have a lot of families. So, like, technically, yeah, it's unique, but it's just different from what I've dealt with, being mostly on the Linux side, the Android side, and all of that.
Well, it's also just different because Windows inherits a lot of stuff from having to support legacy things like DOS. So because of that, you have these unique sort of challenges and things you have to deal with that you don't really have to deal with as much on other operating systems because they're not built on having that legacy support.
Yeah.
So that's where these sorts of bugs seem to become a problem. So switching from Windows to Linux, our next post is from Exodus, from Interrupt Labs, and is a post by Maxploit on a Linux kernel vuln in IPv6 routing, specifically routing for low power and lossy networks, or RPL source routing. And it's in the networking stack, so they do go into a fair amount of detail on the relevant structures for that area, the most relevant one being socket buffers, or skbuff. So socket buffers are used for handling most network data, and they consist of a head, tail, data pointer, along with the length. And there's some helper routines for pushing and pulling data to and from the start of the buffer. But you have to take care that like the data is not going past like the tail or anything like that. Like you have to take some care with how the data inside of a socket buffer is structured. So getting into the routing aspect, the routing header consists of an offset to the next header, the extended length, the routing type, segments left, things like that. And then there's the auxiliary buffer for type-specific data. For RPL, that consists of information needed for decompressing addresses. So one of the things RPL seems to support is this idea of compressing addresses. So you can have this body that consists of a vector of addresses, and then specify compression information. So compar-L will consist of the number of octets to emit for all of the addresses except for the last one, and compar-E has the number of octets to emit for the last address. And using that information, you can use that for the incoming data to figure out which address information you can emit and sort of derive on the other side without all that information being passed through. I'm not sure of the history of why they have this address compression, but I guess if you're passing a ton of addresses, it probably adds up to making it worth it. So
IPv6 they're kind of big. Like, what are they,
that's
16
true.
bytes?
Yeah, IPv6
So,
addresses compared to IPv4 are quite a bit larger than like just a 32-bit int, so it might
yeah.
make more sense there as well.
They're talking about, I think, sending up to like 30 some of the 30. Yeah, at one point here, they're sending 32 of the 1 byte addresses. So, like, if those were full addresses, if they could send that, like, it really adds up.
Yeah. So compression, like, it makes sense to do it here. They are able to save some data and going across the network. But of course, that does add some complexity because you then have to be able to deal with edge cases. So the edge case that they focused on here is what happens if you have a compar-L and compar-E value that makes it impossible to recompress the addresses. So the example they give here is like a compar-L of 15, so that each address only has 1 byte. Or each address except the last address, and a compar-E of 0, so that the last address has the full 16 bytes. In this case, you can turn a 48-byte large address vector into 528 bytes on recompression. And I say recompression in air quotes because it's kind of a misnomer in this case. I'm not exactly sure the maths of why the recompression gets that large. I think you'd have to be intimately familiar with the compression algorithm and everything to get that, but what's important for the bug is that it happens. So
Oh,
because you
so
get such a large...
I do
Go
get why
ahead.
this happens, actually. I know we were talking about this right before the episode, and I was a bit confused. But the issue is because um you've got these two values, the CMPR-E and CMPR-L. So when you're on the last one, segments left equals to 1, that's the one that's uncompressed. And now that's going to be part of like the main body again after this step. So none of them can be compressed because it can't apply that, like stripping the 15 bytes. It can't apply that to all of the other addresses because that one is sitting in there that needs all of the bytes. And thus it multiplies the size.
Fair enough. That makes sense. So yeah, because that happens, it when it then calls skb push to add the address vector to the head of the skb, if it doesn't have space for those 528 bytes, it'll cause the data pointer to fall below that of the head pointer, and that's relevant because if we go back up to the top and look at skb push, they have this like bug check where if the data is lower than the head, it'll trigger a panic condition. So that ultimately leads to a DOS. So it is kind of a cool and subtle bug. Something that would be very hard to catch just reading the code. It's something that I think would be more likely you'd catch through like dynamic testing, like fuzzing or something like that. But it is triggering a DOS. I don't think you'd really be able to exploit this beyond that because you're triggering a panic here. I know we don't cover DOSes too often, but I still think the way that this bug worked was pretty cool. Especially like when you deal with like compression and things like that, you get some interesting cases you have to handle that you don't really see in other places.
It's a clever bug, just in the way that works. It requires, and in the way you're kind of hitting it. Also, as a DOS, like, I mean, harkens back, like a really old school bug was the ping of death, which was just sending a large ping packet. And you could just take anybody off the internet by sending a large ping packet to them for a little while, or almost anybody, it felt like. And so this is basically, you're kind of getting a similar DOS in that you just need to be able to send this IPv6 packet to them. The internet has changed since the days of the ping of death, which I'm just trying to look up here exactly how long ago that was, but like I feel like that was 80s or 90s. Like it
I was
was.
gonna guess like early 2000s. I didn't think it was 80s and 90s. I guess I was.
I don't have the Wikipedia here isn't showing me any date, so
Okay.
not exactly sure on.
Basically, a long time ago. That's what we can summarize it to. So yeah, the internet has changed a good bit since then. So I'm not sure how impactful this would be compared to that. But and as far as DOSes go, I guess it is a little bit more practical and useful than some of the other ones that you see out there, where it is in the networking stack and whatnot. So that's a fair shout as well.
But yeah, I
Uh,
do think like just in terms of how it happens, like I think it's a cool bug, regardless of um like not being able to take it to code execution. It's still a fun bug. I mean, getting a DOS from a network packet, I think's pretty solid. I don't know. I guess then I'd have to say like getting a crash on. I guess the big difference here is this is crashing the kernel. This is operating system level. This isn't just crashing an application. We don't tend to talk about the application like denial of services. I mean, sometimes we do when just you have a bug that isn't exploitable that needs another bug or something. But in this case, like it's the operating system. It's taking, in theory, down the entire server or just the
which in some
QEMU instance if you're on the cloud.
Yeah, which in some cases could be quite significant. All right, so let's get into our shoutout section of the show. So up first for shoutouts, we have a Google Chrome V8 issue from Exodus Intelligence. Uh, we would have tried to cover this as a full topic, but honestly, just kind of ran out of time and got lost in the business of other stuff we had to do, so we didn't get enough time to get a good grasp of it. The vulnerability is in Turbofan, as you can probably expect. Most of the V8 bugs nowadays are coming from that area, which is like the jet optimization stuff. So yeah, Exodus Intel usually puts out some pretty nice blog posts. This one goes into a fair amount of background on Turbofan and the relevant stuff for the vulnerabilities. So if you're interested in browser stuff, I think this would definitely be worth checking out. Um, a lot of the times with browser, a lot of the knowledge you pick up from one write-up will carry over to other vulnerabilities, whether those be other ones that you're trying to exploit that are known or even just finding new bugs. There tends to be a lot of like knowledge sharing that carries over with browser. So definitely wanted to give this a shout for anyone interested in that. But yeah, we just didn't get enough time to cover it as a full topic. As another shout, as I mentioned at the top of the episode, I will be giving a talk at Hardware I/O. It's going to be talking about the PlayStation 5 internals, mostly focusing on like the hypervisor and the security aspects of it, and how exploitation has had to shift, going from the PlayStation 4 to PlayStation 5. So I think it'll be an interesting talk to some people out there. Uh, that'll be at June 3rd, I believe. Yeah, it's the second day of the conference that I'm giving this talk. It's at the 2 o'clock slot. Like I said at the top of the episode, it won't be live, but it should be up on YouTube or whatever within a reasonable amount of time, as I believe the hardware ones usually are.
It
I'm
might
not
be
going to be
live if you're
dropping.
there.
Well, yeah, it'll definitely be live if you're there. But yeah, I'm not going to be dropping like O-Days or something live on the stage or anything like that. I will be speculating on some techniques and maybe some things you could do to get around certain things. But yeah, if that sounds interesting to you, feel free to check it out. And like I said, if you are going to Hardware I/O or if you want to plan to go, feel free to hit me up and we can see if we can meet up or something at it. Though I will be pretty busy. I'm good. That's going to be a packed week for me.
So
Yeah,
you will be dropping a jailbreak though?
no. And yeah, getting into our last shout out. So Z, you have some resources for while we're away, where this is our last one until we come back until the summer. So I'll let you go through some of those and then we'll wrap it up.
Yeah, I just figured since we're going to be gone for a while, some of you may be interested in other resources that you can follow. And I guess one of the main things that I will mention is our Ode fans website. Mentioned it a handful of times, but this is a site I built largely out of doing kind of the work of trying to find resources for the podcast. I end up following a lot of feeds. So this aggregates a ton of those feeds, brings together what are hopefully mostly the vulnerability write-ups. Unfortunately, right off the top here, you can see some that aren't really vulnerability write-ups. But it tends to be a lot more focused on the vulnerability write-ups from a number of different feeds and locations. And it kind of lives off of my feed reader. What it'll do is it'll look at what I've got in my feeds and then like look at all of those. And I have some marked to go on this, so as I find new blogs or add them there, O-Day fans will improve. But I do have kind of the more complete list of blogs that people can check out too. From that, that's if you're looking for like the write-ups and all of that. If you're looking for podcasts, I'm going to give the same 3 kind of podcast shoutouts I gave for a bug bounty episode. Starting off with Critical Thing, it's a bug bounty podcast. They aren't really talking about the binary exploitation, but they are talking about actively hunting for bugs and techniques on that side. So I do think there's going to be some overlap in interest, but yeah, it is a lot more of the higher level web app stuff, and of course they're going to be talking about recon and some things that are a bit less applicable to the binary side. But I think there's a reasonable chance there's some overlap in our audiences on that side. Absolute AppSec is a podcast I've been listening to for a little while. They're application security focused, so again, they are higher level. Unfortunately, I don't know any other like low level binary podcasts that actually get into that. But the nice thing about Absolute AppSec, they do talk about things like code review, about actually they do a course on code review, which I have not done, so I can't speak to the quality, but their experience, have been in the industry for a while, have a lot to say, have some good discussions on there. They're a lot more on the discussional side and discussing kind of things that have happened recently rather than specific vulnerabilities. But they do get into a lot of kind of the more practical side of AppSec, and AppSec code review, code analysis definitely applies to kind of doing the vulnerability research for memory corruption, although they're not generally focused on the memory corruption side, and have made a handful of comments, not necessarily against that, but kind of treating that type of research as a bit more of the flashy stuff and focusing more on fundamentals, I guess. Nonetheless, I've enjoyed them. Open source security podcast falls in a similar discussional feel. I go back and forth on whether or not I actually like the whole episode, but they generally have some good discussions talking about recent security news, things that are going on, and definitely have some opinions that are, well, they'll disagree with each other a lot more than Specter and I will, so they have more just back and forth discussions on, you know, some policies or their own experiences doing stuff, and generally focused on open source. So a few different podcasts you can listen to if you're looking for some other resource while we're gone. In terms of the links, I've already mentioned O-Day fans, but I'll mention the AppSec e-zine, and I just follow their commit feed because that's the only place I know of for it, actually, but they just have like write-ups and stuff. They have more on the red teaming stuff, but if there are binary write-ups, we'll often see them in here also. They'll just collect them there. Similar vein, Bad Sector Security does a lot, or Bad Sector Labs does a last week in security. Similar thing, just collating a bunch of write-ups that have gone out. You'll see things that we've covered, like we talked about the printer goes burr, I think was a last week topic. And this is actually, I was going to say they haven't updated this in a couple weeks because their last one was on May 9th, but I guess they have their May 22nd one now. Yesterday they didn't. Or at least they didn't when I had looked. Anyway, they get a bunch of links, so worth checking out. And last one I'll leave you guys with, Maxwell Dolan is a resources. He does summaries of vulnerabilities, so similar to what we do. Actually, I guess, talked about the CSGO bugs that we've talked about. It's had more crypto stuff, but he'll cover binary vulnerabilities on here also. And he's got a blog, which is solid, and has had some binary topics on there also.
All right, so yeah, I believe that's everything, right? Do you have any other things you want to say, or any other links to shout out?
Uh no, I mean that's all of the kind of references I had. I had a couple more on our bug bounty episode that are more uh websec related, like a couple Reddits there, NetSec, but most people already know about that, so I don't think I really need a. I mean, technically, I did just shout them out, but yeah, no, I think that's all. Hopefully, that's enough to keep people occupied while we're off on our summer break.
Yeah. So as always, thank you goes out to everyone who listened. If you want to go back and check out past episodes, you can find the recent ones on Twitch, and all of them are on YouTube, Spotify, Apple Podcasts, and more links off of Anchor. Uh, while we will not be doing the scheduled streams, we will still be around on Discord and whatnot, so feel free to join that. Link for that is down below or in the chat. And also feel free to shoot some ideas in there for the Spot the Vuln shirts if you have some as well. Just a quick reminder on that as well. And yeah, so we'll be back on September 25th and 26th. Until then, wish you all a happy summer, and we'll see you then.